Okay, so hello everyone. I'm Jintian from TU Eindhoven, and I'm a PhD candidate from the Information System in the Built Environment group. Today I will present a data-driven decision support framework for prioritizing reusable building products from Dutch demolition flow, and for diagnosing barriers to product level reuse. I will start with the context. So as we all know, the building material is uh, has a very large value for reuse, but nowadays most of them are just for downcycling. And for reuse part, most of them need a product level reuse. So a product group means components with similar function and the materials, such as brick, core slabs, structure stairs, and window glass. And the product level reuse requires keeping components intact for another use recycle. And here comes the research question. So the research question asks how high potential reusable product group can be identified from Dutch residential and utility buildings demolition outflow, and how the key implementation barriers can be diagnosed. The study contributes through 3 connected steps: screening and ranking, and also map barriers. Here comes the method part. So as I said, the stage 1 is the screen part. So the workflow starts with the Dutch residential and the utility buildings demolition outflow. So there are 139 product groups, and we try to cleaning and merging it, and we use the mass outflow times environmental cost indicator, and finally we get a short list of 10 candidates for stage 2 to give it a ranking. And for ranking part, we use mainly use 2 methods. Firstly is the multiply critical analysis. So we have these 5 criteria, including cost barriers, supply-demand balance, technical feasibility, risk and liability, sustainability impacts. And also we have some expert interviews. We use the best worst method to get a weight to help us to get a procedure of this study. And I will move the stage 3 to next part, but here shows the results. So based on the stage 1s, we can get the 10 products groups to see which one has a high environmental cost. So we can see that top 2 is white slab floor, and the second one is the bricks masonry. So here's the first result. And result 2 is based on the experts interview. So we have the expert panel from cross sectors. There are 8 experts, and we use the best worst method to see which indicator is highest as based on the experts version. So supply demand be seen as the highest one in this study. And we, after applying the multiple criteria analysis, the bricks masonry ranks first with a score of 4.04. So ranked first in the whole 10 things, and heavy stretch still ranks second. Yeah. And we follow it, make a barrier mapping for this. So because from stage 2 we get a ranking, and we based on this ranking we get a stage 3 with map barriers to see that how this work really in a real situation. So we identify the bottlenecks behind the top ranking candidate, and we're using stakeholder interviews and barrier categories. So here comes the barrier mapping result. We chose the bricks as we studied group for this part, and most because also the steel is also the very high ranks in the formal part, but steel is already have so many reuse method or so many reuse case. But for bricks, it's most of time still downcycling. So that's why we try to find out what's the real situation between bricks. And we use these two methods, case-based barrier diagnosis and also value chain mapping, stakeholder interviews, and the research drive barrier categories. And here comes the result part. So there's also several indicators we should consider about, so including the material condition, quality assurance, and the process coordination. And here comes the conclusion part. So we can see the environmental relevance is not enough when we try to define which material groups, product level groups should be considered as the first part to reuse. And also implementation conditions change the ranking, and the ranking should support diagnosis. And yeah, here's the full part of our research. So from screen rank and the map barriers, and finally we got some intervals related to quality, timing, and coordination. And also here's some need future improvements. So data can be strengthened through better environmental cost indicator assumption, product level variation, and the mass flow uncertainty analysis. The decision model can be extended with uncertainty propaganda, and the implementation work can further develop. Yeah, thank you, and welcome your questions.